Welcome back. It's my pleasure to introduce our next speaker. So Machado is a senior petroleum engineer at Petrobras with extensive experience in reservoir engineering and field management. Since joining Petrobras in 2007, he advanced to the role of a senior technical advisor in 2020, specializing in project development, human resource training, numerical modeling, and CCUS initiatives. Dr. Machado holds a PhD in reservoir engineering and completed a 2-year postdoc program at the University of Texas at Austin in 2024. He also teaches part-time at PUC Rio University and has authored over 80 technical manuscripts, including research papers, conference papers, a book on reservoir simulation, and internal workshop presentations. His focus is on optimizing reservoir performance and mitigating risks in gas storage projects. Marcos, please, the stage is yours.
Good afternoon, everyone. Good day for the people connected remotely. I'm pretty honored to be here representing my company and talk with this opportunity to talk to such a distinguished audience met in Rio. I'd like to take this opportunity to welcome you all to my country, to my hometown, Rio, to my neighborhood, Copacabana, and actually to my block, because I live on the street behind the hotel. Welcome. So my goal today is to present this talk. This talk was prepared by my mentor, Dr. Daniel Miranda, and myself. And our idea is to share some perspectives, some insights. It's not an institutional talk. It's not an institutional presentation. It's like a merge between our insights, our thoughts that we want to invite you to share and to think about how is relevant the oil industry and its pivotal role in this process called energy transition. So I would start with the outline of the presentation. And the key topic that I plan to cover, I will try to address how the global challenges in terms of climate change are shaping the energy demands and the policies that we are currently face. The second point, I will cover the energy transition, but I will try to describe the energy transition in a broader landscape. And after that, we talk about some specifics for oil and gas industry. And the finish, I will wrap up some takeaways of this process. So let's address the global challenges that frames our discussions on the greenhouse effect, and use this challenge for fostering innovation and transformation in the energy system worldwide. So as you can imagine, I'm not an expert on greenhouse effect, but I would like to invite you to recall the key mechanism behind this effect. The solar energy from the sun penetrates the atmosphere, and part of this energy is heated back out to the space. However, due to the concentration of gas in the atmosphere, part of this heat is trapped, warming the Earth. And the consequence of that, the side effects of that, are some adverse natural events that we are currently faced worldwide, such as the fires. So much more common and more frequent, the fires events in countries like US. Every year we have news from US about fires in California or at the border with Canada. In Brazil, it's very critical, the floods, especially in the south of Brazil. We have facing this problem with more frequency. Other countries like coastal cities are concerned about the sea level rise, and arid and semi-arid areas are facing some events related to the water stress. But how we can react to that? How we can talk and we can together, we need to team up and reduce the greenhouse gas emission. How we can do that? How we can figure out and figure out solutions to handle those issues. I would like to try this answer about how to reduce the greenhouse gas emissions inspired by the book released by Bill Gates in 2021, How to Avoid a Climate Disaster. In this book, in a very direct and simple language, he invited us as society as a whole, not as people, but including government and including companies, that includes the oil and gas industry, to change some behaviors and how we handle some things in our common life, routine life. For example, he invites us to change the way how you generate electricity. Try to combine not electricity energy matrix based on fossil fuel, but combined and migrates to a more diverse matrix combine renewables and fossil fuels. Another way that you need to change is the way how you make the things. This is very critical and crucial for us in Latin America, where hard-to-abate industries such as cement industry and steel industries that are critical and crucial for our economy, including in Brazil. But you know the amount of emissions generated by those industries should be handled. So we need to find ways, need to figure out how to make the activities of those industries more sustainable. And the last thing, how to grow things, how to grow crops, livestock. That's critical for us, again, in Brazil, because we are agricultural country. We need stocks, we need crops, we need livestock to move our economy. So we need to recognize the potential source for emissions and figure out solutions to handle those emissions together, including the oil and gas industry. So let's delve into the energy transition, and which I prefer to refer to them as energy addition, was mentioned in this conference the day before. So I think we need to move forward, combining new sources of energy, wind, solar, hydroelectric power, that's another natural vocation of Brazil, with fossil fuels. So diversifying the energy matrix is a way to ensure a balanced and more resilient energy system. For that, I do believe that the transition concerns should address the balance among those topics about energy security, equity, and environmental sustainability. Successful energy transition must ensure reliable energy supply, fair access, and benefits for all communities, and minimal environmental harm, reflecting the multifaceted nature of the global challenge. Let's go over each of these topics from this slide. In terms of energy security, we need to take care of 4 key areas: the production, transportation, storage, and consumption. For instance, an example of energy security would be ensuring a stable supply of energy by diversifying the energy source, combining fossil fuels and renewables, and invest in the infrastructure to prevent disruptions in the energy supply. We need to move forward and make our grid more robust. For equitable transition, we underscore another key elements: the demography, the industrialization, economic development, and natural resource. An example of that would be implementing policies that ensure for all communities, including marginalized and vulnerable groups, have access to the benefits of the energy transition, such as job opportunity related to the economic development and affordable clean energy. In terms of environmental sustainability, we'd like to outline that we need to combine the 2 sources of energy. A source called renewable energy, solar, wind, hydroelectric power, and I would like to highlight the bioenergy is another natural vocation for Brazil, for an agricultural country like Brazil, with the use of fossil fuels. In another way, you need to figure out how to make this activity more sustainable and emphasize the use of natural gas and combine different sources of energy. From this topic, I will discuss some specifics for oil and gas, give you some examples how the oil and gas industry can show the protagonist on this process. I do believe that the oil and gas industry should be the protagonist, rather than antagonist in this process. We need to lead this process, make specific actions that can undertake the energy transition in this moment. For that, we need to take care of all emissions. I think all the emissions count. We need to consider the Scope 1, the Scope 2, the Scope 3 emissions. Understanding all the scopes is very crucial because you need to have an effective management of those emissions for achieving substantial decarbonization results in a broader perspective. And for that, I think the first step toward achieving greater protagonism in this process is to change the way how we optimize the process. I think the oil and gas optimization projects needs to combine a dual objective function. We need to enhance our oil and gas recovery, combined with less emission, reduction in the emissions of greenhouse gas emissions. So I know that's not easy. We discussed a little bit about it during this morning, but I think we have the best people met here that can help us as an industry, as universities, as researchers to work together, need to team up, and to find ways to move in this direction, reducing our carbon footprints, improving the recovery of non-renewable resources, and encourage a balanced energy mix. I think this effort aims to make existing operations more sustainable while integrating with a cleaner energy source. In summary, the oil and gas industry can adopt several strategies to achieve the net zero emissions. These strategies involve optimizing process to reduce the greenhouse gas emissions, replacing high carbon energy sources with cleaner alternatives, and capturing and safely disposing of emissions. In this process, I'd like to highlight the CCS as a potential technology that can contribute significantly to achieving the net zero emissions. And from now onwards, I will discuss about how the CCS project can be highlighted to ensure a practical and effective tool in reducing industrial carbon at scale. It's very important for us to emphasize that we need to operate CCS project at scale because we need to take care on not only our own emissions, we need to help the other sectors of the industry, as I mentioned before, hard to abate industry, to move forward in the reduction of the emissions. In this slide, I would like just to put everybody on the same page about CCS. CCS, as you know, is a process where the CO2 can be captured from different emission sources, and this CO2, after capturing, needs to be transported to the storage site. The storage is done mainly in underground formations, such as oil and gas depleted reservoir or saline aquifers. For the planning, for the deployment of a CCS project, the first step is to start with the site selection and the assessing of the site regarding its potential capacity to store the CO2. After proving or after get some evidence about the potential capacity of this site, we need to plan the project and get the approval to start the project. After some assurance process and getting this approval, we need to build all the facilities to pipe the CO2 and to inject CO2, and more than that, we need to make sure that the CO2 can be injected during this time in a safe way and efficient way. Even after the post-closure of the site, we need to make sure that the CO2 is perfectly contained in the porous media. So this slide summarizes the key steps for the deployment of a CCS project. Petrobras is moving in this direction. Petrobras has been operated the largest CCUS project in the world. Is the operation in our pre-salt fields offshore of Santos Basin. Part of the CO2 that's produced from the native oil is separated in the floating units and injected back into the reservoir, alternated with water to improve the oil recovery. So this is done with minimal emission, and so far we have captured around 13 million tons of CO2 a year, and you have the goal to achieve at the end of this year 8 million tons of CO2 reinjected into those reservoirs. These are the CCUS operated by Petrobras in our pre-salt fields. However, we are moving forward. We are now dedicated to study dedicated CCS in saline aquifers. So we have the potential if you combine all the Brazilian industrial emissions, we have this potential, to be injected, to be stored. This emission is mainly concentrated in the coastline of the Brazil, is where the industrial activities are concentrated, and huge sedimentary bases occur in this area. So we can take advantage of the proximity between the storage site and the location of the industrial activities of Brazil. We are planning, we are studying some hubs, some potential hubs to be deployed in the Brazilian area, but I will detail a little bit about the hub that we are planning for the Rio de Janeiro state. This is the map of the Rio de Janeiro state. And our idea is to capture the CO2 from different sources, from cement industry, power plants, refineries, and pipe the CO2 using existing pipeline to be injected in a saline aquifer in the offshore of Campos Basin. So it's an offshore project, it's an offshore aquifer because you need a huge aquifer with a huge pore volume with ideal capacity to handle all this amount of CO2 that can be captured from the industrial operations in real estate. But before moving to our offshore environment, our idea is, let's start smaller. Let's start doing a pilot in the onshore area, this location called the Barra do Furado, in the same aquifer, the same sedimentary base, piping the CO2 from this gas unit treatment using this existing pipeline. Actually, we need to repurpose this pipeline and monitoring the CO2 behavior in porous media over some years after the injection shut off. This is called the São Tomé CCS pilot project that we announced the last week, the final approval to start the operation in 2028. So our plan is to inject over the course of 3 years, starting, actually it's 2028, not 2027, in this saline aquifer. Is a sandstone aquifer, high porosity, high permeability, conditions of pressure, salinity, and temperature favorable to enhance the amount of CO2 in the brine solution. So it gives us some, it reduces the risk of the project because we expect that part of the CO2, significantly part of CO2 can go into the solution. The CO2 will be captured from this gas unit. It's part of the CO2 that is produced in the gas, natural gas from our pre-salt fields. The amount of CO2 is around 100 100,000 tons a year, and our plan is to inject over the course of 3 years. Okay, we'll pipe the CO2 using this pipeline, 6-7 kilometers of pipeline from this location, the capture site, to the storage site. We plan to implement, to deploy different techniques for monitoring, but I will detail only the three deviated wells that will drill on the outskirts of the wellbore, the injector, and we plan to use these monitoring wells to measure pressure and to get samples, in situ samples of brine, to calibrate our numerical model in order to see how predictive our model is to predict the capacity of the CO2 goes into the brine solution. So we need data to monitor the wells, you need data to calibrate the wells, and you need to implement and test different techniques and see and do like a screening of techniques before going to our offshore environment. So this will generate a bunch of information for us, lesson learned from this project, and we have a great expectation about the learning and the finds that we are planning to do in this pilot. In terms of inventory, we expect part of the CO2 will be trapped, permanently trapped as a residual phase by capillarity, and another part will be trapped as a soluble phase in the aqueous phase. Another mechanism, such as mineralization, fines migration, hydrate, salt scale, were deemed irrelevant according to several numerical models, lab experiments that we have done in the years before the project planning. This is the final inventory that we expect to see for the CO2 injection. During the injection phase, most of the CO2 will be mobile in porous media as a supercritical phase, but after the injection shut off, part of the CO2 will go to the brine solution, or will be snapped off by the water in the porous media. So let's finish with some takeaways. My idea is just to wrap up some takeaways, point out in this lecture. I'd like to say that in this concept of energy transition or addition, the new oil and gas industry has to play a critical role. The new oil and gas has to be the key player in the energy transition, work to generate a balanced energy mix environment, lead to CCUS movement. I do believe that CCUS is a potential technology to be deployed by the oil and gas, because you know how to pipe fluids, you know how to inject fluids, you know how to monitor fluids, you know how to calibrate models. So it's a natural vocation for our industry to move in this direction. And after doing this, I think we can play a major role as a protagonist in this process. And just to finish my last slide, I'd like to say that the main assets of the oil and gas industries is not its oil reserves. I think the main assets are its staff, its crew, and the capacity of these employees for innovation. I do believe that the oil and gas industry should capitalize on these strengths by developing work-phase capabilities, utilizing accumulated knowledge, and encourage innovation. These factors are crucial for adapting for new challenges and technologies within the energy sector. Collaboration and fostering innovation with practical and doable solutions like CCS will be key drivers for our success. We will not miss the mark in this matter. Actually, you cannot miss the mark to save our planet. Thanks so much. I'm open for questions. Thank you for the opportunity again.
Thank you, thank you. Questions from the floor?
Thank you, Marco. What is the role of Petrobras and the role of the government of Brazil in these CCS projects that you're describing?
Yeah, in this case, Petrobras is the operator. Petrobras is in charge of planning all the operation from the capture step to the storage step. In terms of government, Petrobras will you do this pilot using R&D resource. So the government will give us some tax relief to use part of this resource that should be used to sponsor R&D project, and we will use this resource to sponsor this pilot. No, we don't have regulations. The regulation that we have currently is just to do the operation. We have the permission to operate in CCS in a Brazilian subsurface, but we don't have incentives, don't have tax reliefs, don't have so far.
Am I allowed to ask a kind of a really technical question?
For sure,
around the
it would be a
pilot?
pleasure.
Okay. Well, it's a bit selfish because I hadn't realized the details of the pilot that you were running. So you had, it was the conclusion that salt precipitation is not going to happen, which was kind of interesting because the conditions, if I remember correctly, at the depth, temperature, 100 and something grams per liter or something salinity, it's exactly the same as Quest. Quest is already in their 7th cycle of trying to actually remove precipitation from their wellbores. I mean, in Aquastore, our precipitation is crazy. I mean, 330 grams per liter. It's like crazy seawater. So I don't know why that part. It's kind of interesting. And then the second part was in this pilot. The part that's always intrigued us around some of these things is how important is it in this environment to determine what the natural hydrodynamic regime is in an open system like this. So what is the groundwater velocity flow? Because even small amounts of gravity or groundwater flow will affect all of this fancy stuff if you assume it's just sitting there. Life changes very quickly if even it's 10 meters per year. So kind of the two questions is that the salt precipitation, why you've concluded is 0, and the hydrodynamic regime.
Thanks, Professor, for the opportunity for clarifying these points. In terms of salt scaling, actually we expect some salt deposition, but we do believe that the high porosity and high permeability, in this case is a tube Darcy sandstone, will offset part of this impairment in the injectivity. So the salinity is around 55,000 ppm. So 65,000 ppm is 5 times lower than Quest. So according to my calculations, we expect a reduction to 91% of the initial injectivity. So, but the amount of CO2 that we are planning to inject is too small. It's 100,000. The thickness of the area is too big. So I think all the combination of high permeability and high thickness will offset any injective impairment during the injection time. So, and regarding the flux, the natural flux of the aquifer, we included this in our modeling. We expect some distribution in the CO2 plume during this process. However, as we expect that most of the CO2 will go into the brine solution, we believe that this mechanism will be reduced because most of the CO2 will be in the solution and concentrated at the deeper part of the zones. So according to but it's one thing that we need to clarify with monitoring data. So this is one goal of our monitor point. Thank you so much for the questions.
Let me ask a question. In addition to the technology, government policies and whatnot, there's going to be economics at some point in time if someone's going to try CCS without the EOR part of it that you'll make money from the oil. So what price on the CO2 would you, if you have done any economics, to break even? For example, in Canada, we're talking about $135 US per metric ton by 2030, and then by 2050, $200 per metric ton. So have you done economics on that and see what price of CO2 it would help the economics in breaking even?
Yeah, we have done, but for us to split the numbers is a little bit complicated because we plan all the facilities to be used in other projects. So this idea is to inject CO2 over the course of 3 years, but the facilities that will be repurposed for this goal will be used in another project. So it's complicated to split the cost for this project from the cost for the expansion to the offshore environment. So in order to reduce the cost, our idea is to plan in a broader perspective, including other projects together, to reduce the capex of the project.
Okay. Well, thank you very much. Duke, you got something? No? Okay. So, well, once again, thank you for the talk.